Okay, we're 5 past. We are going to record this and post it to the internet. So I would suggest that we do what you wanted to do and then go from there.
Sure. Yeah, basically, I can give kind of like a little bit of a deeper dive into Kurtosis for those who are interested and for those who are watching this in the future. Just as a really quick, I guess, recap, Kurtosis is a platform for doing development and testing for distributed systems. The idea behind Kurtosis is that you can leverage your Docker engine. Docker is your kind of underlying container engine, and then Kurtosis provides an abstraction layer on top of that in order to do things, various different things with that. So the principal idea that we have, and actually, I usually am a big person who likes to draw. So I'm gonna try this. Let's see if this works. Let's do this.
I think I broke something. I sent the wrong link on Discord.
I got it.
I think I sent
Maybe
my,
folks.
well, let's see. Pooja, are we in 8737 right now?
Let me check. Yeah. I think there is a way to invite it.
There's a wrong link on the, okay, I'm going into the other. I'll be back. I messed up.
So this is the link.
Yeah, I got it. I'll be back.
We were all in another room waiting for this to start. So there should be a group of probably 9 or 10 people joining.
Oh, awesome.
I
We're
love
like,
it.
we know people are busy, maybe folks just weren't interested in the session. So
Hey, I'm really sorry. I messed that up. We changed this was set up by Tim. We changed the link to a calendars link so it would record by default. I changed it on a calendar invite. I didn't change it on the PM repo. I then confused myself today and sent the PM repo link and also went to the other link. The internet is difficult sometimes. I very much apologize. This is totally my fault.
No worries.
Yeah, we were like, damn, nobody's coming. Okay.
I motion to replace Danny.
Dude, I need a vacation. I'm okay with that.
All right. Looks like we got a bunch of people popping in now. Cool. So this is super exciting. Okay, so welcome everybody. Thanks so much for showing up to our little working session. My name is Kevin. I'm the CTO of Kurtosis. You might know me as Brees on your Discord channel because I probably bothered every single one of you on your Discord. Apologies for the pestering. That was me trying to get everything working with the Ethereum module. So to kind of give a quick recap about what Kurtosis is and what we're doing, the idea is that you're able to set up like test nets and do all these things with Docker or with Kubernetes, kind of depending on your flavor. But as I'm sure anybody who's done this knows, there's kind of a lot of work that you have to do in order to get that going. You have to understand some fairly low-level stuff around Docker and especially around Kubernetes in order to write the charts that you need. So Kurtosis provides an abstraction layer atop Docker, and we're currently working on providing Kubernetes support as well, which will allow you to work with these with distributed system networks much easier. So in the Ethereum context, the idea is basically we have built a, you can almost think of it like a little application that inside of Kurtosis, which really means inside of Docker, you can spin up a testnet or a local dev net, I guess you'd call it, which contains 2 halves, contains the execution layer clients up to your specification, as many as you want, with various different flags and logging levels and such like that. And then after the execution layer clients are up and running, it will create CL clients, CL client network. And then that's going to be with various different configuration parameters that you please in order to get things working. And then after you have both of these running, you can just leave the network running and it will eventually perform the merge. So that was a lot of information dumped at once. So I'll take a couple steps back now and just give a really quick walkthrough of the kind of fundamental concepts of kurtosis, and then you guys can will eventually culminate with running the merge module, and you guys can go ahead and see this. So kurtosis is a CLI, and that CLI is installed by a package manager. I'm on Mac, so you could just do brew install kurtosis tech / kurtosis CLI, I believe. I'm not remembering the exact incantation right now, but we have installation docs right here. I'll go ahead and send to the group. Yeah, here we go. Kurtosis tech / tap / kurtosis CLI. And that will get you kurtosis on your machine. However, if you're on Linux, you of course will have a different package manager. So we have installation steps for those as well. Let me get this a little bit out of the way. Hang on. So once you have kurtosis installed on your machine, we ask you to make an election about whether you'd like to opt into our metrics program. Obviously feel free to make whatever choice you want on that. We use the metrics only for product analytics. So making sure that we know what things people are using and what things are worth throwing engineering points behind. So once you have kurtosis on your machine, you are going to have the kurtosis CLI right here. And that kurtosis CLI, the first entry point that you work with the kurtosis CLI is enclaves. So enclaves are like little walled gardens that you put your distributed networks inside of. And very concretely what this is a Docker network under the covers that you start all the different machines, all the different services inside of. And I'm a big drawer. I like to doodle. So I'm gonna go ahead and do one of these guys. And we can hopefully make this a little more visual too. So you have the boundary for your Docker engine. And the enclave that you create here is going to be a separate network. And we can go ahead and see this if we do kurtosis enclave new. And what this is going to be doing under the covers is creating a new Docker network. And then you're going to get back a new empty enclave. And then if I could do kurtosis enclave ls, you can see that I have one enclave running with this enclave ID right here. And if I do kurtosis enclave inspect, then I can inspect this enclave and it will be empty. So inside of my Docker engine, I have created a Docker network, and we can see that this Docker network corresponds to the name of my enclave ID here. So kurtosis provides like a couple tools for doing things with enclaves. Like we can go ahead and remove this enclave as well. And kurtosis will go ahead and do that. And if you had any services inside of it, it would blow that all away. So that's kind of the enclave concept. So enclaves will be the most macro unit object that you'll deal with. So now for the Ethereum context, we have a module, we call it. Modules in kurtosis are like packaged set of instructions to the kurtosis engine. So once you have an enclave, of course, you want to start stuff in it. And that stuff that gets started are going to be containers. So we could imagine that we have something like this. And we could have like a geth service and maybe another geth service. And maybe we have Lighthouse. And maybe we got Nimbus as well. And you would start all these services inside of kurtosis, and you could do this manually. So we do have an SDK for communicating with the engine. So you'd have a little bit of a library in Go or in TypeScript that's out here that lives in whatever code you want. And then that would communicate with the kurtosis engine. And you could basically write all the code necessary to set this up. But then you'd have to have that code maybe as a library on your machine. Maybe you'd write it as a bash script, as a bunch of CLI commands. It gets a little bit unwieldy. So we have this notion of modules, which very concretely are a little tiny gRPC server that responds to one command, which is execute. And that is a container as well. And what that will do is that will package up all the instructions to the kurtosis engine so that all this stuff is encapsulated inside of the module. I dumped a lot of information, so I'm going to give a quick pause there. Any questions, comments? Okay, so this module is the main thing that we've been working on. It's why I've showed up in all of your Discords to ask questions about what are the flags necessary in order to start all these various different nodes, all these different types of EL and CL clients. So a module is a Kurtosis, because it ends up as a container, a little tiny gRPC server. It is a Docker image, which means that we can distribute it via Docker Hub. So in this case, we have the Kurtosis tech / eth2 merge Kurtosis module. And so this is the Docker image that we use, that we package the module inside of. So you can run a module with Kurtosis module exec. And Kurtosis module exec will create a new enclave. It will launch the module inside of the enclave and it will execute that module. So fairly straightforward. Now, where things get a little more complex is that modules can be parameterized. So in our case, we have configured the module to take in JSON that configures its behavior. So this is how you specify the number of participants, a bunch of different information about the network that is getting started up, like how many validator keys do you want, like what different AppBox do you have. You're able to configure the terminal total difficulty as well, a bunch of different parameters. And the main place for seeing these bits of information is going to be on the module repo page. So right here, we have a, go ahead and send this to the chat. We have a Git repo that contains all the code for building the module. It's written in Go, and it is really, it's a very fancy set of instructions to the Kurtosis engine. That's really all it's doing. So this particular module is configured for JSON, and these will be all the different parameters that you can pass in. So if you'd like to start your EL node or your CL node, you can, for example, set different images here. You can set various different command line parameters if you wanted to set arbitrary parameters. Same thing with the CLs as well. And then, of course, like I said, we have all that networking information here that you can set if you'd like to set it. So none of this is required. This is all optional, and we have defaults associated with that. So we have the module. We have the Kurtosis CLI command, which is going to do the module exec. Again, because Kurtosis has an SDK, you could do exactly the same thing in an SDK. You could put all this logic to execute a module inside of a unit test, for example. So we actually use Kurtosis to test Kurtosis. And what that looks like is the Go unit test framework imports the Kurtosis SDK, and then it tells Kurtosis, hey, please give me an enclave, do this thing inside of the enclave, do a couple of assertions, tear the enclave down. So what we're going to do here is go ahead and execute that module to network config. So what I'm doing here is I'm just passing the execute params to the module via a file that contains the configuration that I want. And that is this file over here. So I've written this JSON file. I like to keep it as a separate file rather than putting it all in the command line, because then I get JSON highlighting. I figure out if I've missed a comma or something like that. But again, you could, if you wanted, you could just pump in raw JSON right here. So to see what this is doing, we can go ahead and look through the logs. So we can see that we've got creating an enclave. So now we're going to have this eth2 merge Kurtosis module enclave. If I come over to a new tab and I do enclave ls, we can see that we have an enclave with that ID, just as expected. And if we do Kurtosis enclave inspect here, we can see that this enclave is starting to get stuff inside of it. So we have one module, which is the module, the eth2 merge Kurtosis module that contains the logic that we expect. And it's starting to start things inside of it. So this pre-launch data generator service is actually a container. And that container is for generating EL and CL Genesis information. So if we come over to our Docker engine, we can see that we do indeed have a container, the pre-launch data generator container, which Kurtosis will use for generating the EL and CL information. And then if we come back to the module logs here, we can see that we have the parameters that we started the module with, and then the module is just going through the various different steps necessary to set up the network. So right here, yep, This is the generation step. Concretely under the covers, what the module is doing is it is calling that pre-launch data generator, getting an EL Genesis file, and then we're starting to add the EL clients, which in this case is only one get client. So we add one EL client here, and now we're going to go ahead and wait for that EL client to start mining. If I was smart, I probably would have flipped the wait for mining flag to false, which would speed this up at the cost of breaking the network slightly. The CL clients would behave a little bit strangely, but in your production tests or in your use case testing, you can go ahead and leave this as true, which will basically say wait until the EL clients are producing at least one block. And then after they are producing one block, we can go ahead and start adding the CL clients. So any questions so far? While we wait for this guy to start mining, any questions, thoughts, comments, concerns? Or maybe anything that's confusing, anything that I'm running through super fast?
Perry had a comment in the chat.
Okay. So, so while we're waiting for this, I can go ahead and give a little bit of a demo of the of the features that Kurtosis provides for debugging.
Kevin, we have a comment in the
So,
chat.
when you have a module, or when you have an enclave here,
Can Kevin hear
a
us?
very common use case
One
is
second,
that you'll want to dump the enclave information. So I think I've chatted with all of you about this, about doing a log dump of all the containers that are running inside of the enclave. So, I do see a raised hand.
Your audio is off.
Hello. Oh no, you guys can't hear me, can you?
No, we can, but you can't hear us.
Oh no. Okay, give me 1 second. I think my AirPods did something goofy.
I can just expand on my comment in the meantime. Since the entire H2 module is just a Docker image, if any of you modify any of it at whatever time, if you want to add a test, or of late, the most common use case has been in my client, I've changed the flag, so I need to change the flag in the module. You can just compile it yourself with scripts build sh and then test it and make a PR for them and they'd launch it for you.
Okay, I can hear you guys now. Can you hear me?
Yes, we could
Yeah, we-
always hear you.
I apologize
couldn't
for
hear
that. I
us.
just started seeing people smiling in the little side window here, and then I was like, something's going wrong here. Okay, where did I lose you guys at?
No, you didn't lose us. We heard you the whole time. There were just like a couple of comments that you didn't hear. Like, for example, Perry had mentioned build scripts.
Okay, cool. I'm gonna shut up then because I'm sure I was talking over people.
Not too much. We've generally been quietly listening. But if anyone has a question, now's a great time.
I was curious how you're generating the CL Genesis states. Like, what tool do you use?
Yeah, 100%. So there is a Docker image, which is put together by, and probably correct me if I'm wrong, but I think SkyleNet is one of the core ETH folks.
It's Raphael, yeah.
Okay. So there is a Docker image that is, I'll go over to the repo here. SkyleNet. This repo right here is a Dockerized version of the tools necessary for creating validator keys and for creating Genesis, CL Genesis and EL Genesis here. So I'll post this in the chat. And basically what we do inside of Kurtosis is we wait a minute. Should go to everyone. So we basically call these bundled tools that are packaged inside of the Docker image. And then there's a flag for calling CL Genesis here. And we pump in a templated CL Genesis config file. Let me get over, my computer's chugging a little bit. So
Gotcha.
To that ETH2 merge module. This is the downsides of a 2015 Mac while running a proof of work miner, while having Golang, doing indexing, while screen sharing. So apologies for a little bit of slowness here. Eventually, we're going to get over to the ETH2 merge module, so I can show you a little bit more about the code inside as well. And can give you guys a little bit of a walkthrough.
In the meantime, also one other question. Can I give the Kurtosis module a Git repo rather than an image of the client and have it compile it? Or do I have to basically do that myself and then create the Docker image locally?
You will have to do that yourself, just because or at least like when we've started, we made the assumption that we don't know anything about how that Docker image is getting built. So like which subpackage it would be in and inside of that. I actually think that's a really cool feature, and it's something that we saw like a complementary company doing, where they basically like always push a Docker image from every Git commit. But yeah, currently we don't do that.
I'm just interjecting there. There's another repo where I've got workflows for I think 4 different clients. If you have a client you want to build that isn't a part of those workflows, just make a PR or let me know and I can add them. And the CI for this runs nightly, so you get an image spit out at 2 a.m. And if you push something later on and you want to just manually run it, you can just run a manual workflow and specify which branch you want. It'll then clone the branch of that client repo and then spit out an image at pari/j/client name.
Nice.
That's super cool. I actually didn't know that. Okay, we're gonna do this the old-fashioned way. So we have the CL Genesis. So the so we have we're inside of the ETH merge module right now. So this is that module that I was showing before, and we have the templates here in this static files subdirectory. So actually, if I was smart, I'd be showing this to you guys on Git. So inside of this Kurtosis module subdirectory, we have static files, and then we have the Genesis generation config, CL, and then we have the information here. So this is really just a Go template, that the module will pump in the correct values for. So that's actually how the CL Genesis file gets concretely generated.
Gotcha.
So we can see now that the EL node has started mining, and now we've proceeded over to the CL client Genesis generation. So that's going to proceed. Normally this is quite a bit faster because my CPU isn't maxed out, but you guys can play around with that on your machine and see how fast. I know, Pari, that you have the M1 machine, and then things are going like insanely efficiently. So I dream of getting one of those one day. So over here, we were talking about having dumping enclave information. So usually if something goes wrong, for example, inside of Kurtosis, it's very useful to be able to see the container logs. So we have this command, which is Kurtosis Enclave Dump. And Kurtosis has the ability, you can see enclave output here. So basically, this is going to start dumping all the information inside of the enclave out to this output here. And if I go here, we can see that everything that is currently inside of the enclave gets spat out. And we can see log files, as well as the Docker container inspect information. And this is super useful on my end, for example, like say Kurtosis does something that you don't expect, like there's an error, a bug, or something like that. If you can provide me with this enclave dump output, that makes things a lot easier from my side, because I can see exactly what Kurtosis was doing on the inside. And we also have the ability here to shell into a service if we want to. So if you wanted to do Kurtosis service shell, and you grab your enclave ID, You grab, say, a given service. Well, let's actually do the get node. Here. And you go ahead and you can get a bash shell. We try to be a little bit better than Docker, and that will try to give you bash first before you do sh, so you're not always stuck trying to like land up in the sh shell. And then lastly, you have logs as well. And if you wanted to say follow the logs, then we would go ahead and start tailing logs as they start showing up. So we can see that we're actually watching the nodes live logs. Any questions about that so far? Okay, so we should be getting pretty close to generating client data, seal client data. And the very last thing that I can show you guys on the code side is how you would modify your particular client's launch within Kurtosis. So maybe you have a flag change that needs to happen, or maybe there's some sort of structural change to the way that the service is launched. Inside of Kurtosis module, inside of Impl, we're going to have this participant network. And I'll show you guys where to find this afterwards. So inside of participant network, we of course have EL and CL, and let's say we wanted to modify the geth node right here. We would go to this geth launcher file. So every client has a xxx_launcher file, which is for modifying the way that the container is started inside of Kurtosis. So every single one of these files, they have just a bunch of constants here corresponding to various different pieces of information that we use for giving for launching the file or launching the client. So you know, we can see mining rewards, accounts, and port numbers and that sort of thing. We have a map of used ports, which are going to be the ports that are exposed for the container. So Kurtosis wants you to tell it about, hey, what are the ports that this container is going to be listening on? And the reason for that, actually, let me do a quick deviation here. The reason for that is because if we come back to this Kurtosis Enclave inspect here, we'll see that every single service here actually has local host port bindings. So these services are running inside of a Docker network. So they are isolated by design so that they can't interfere with each other. You don't have port conflicts and things like that going on, but you still want to be able to access these. So we can see that each of these ports that is now on the geth node right here has been bound to an ephemeral port on my machine. So for as long as this enclave is alive, I will be able to access this geth node via these various ports. And I'm going to do the bad demo thing, which is I'm going to try to remember a command off the top of my head. And Pari, maybe you can help me with this one. If I wanted to get the geth, block number, then I think block number post. If anybody knows it, feel free to.
I just sent it to you. You just have to change the IP.
Say again?
I just sent it to you. You have to change the IP. It's on chat.
Grab that chat. Thank you so much. Okay, so let us grab, so 8545, yes. And there we go. Let's clean that up a little bit. And now we can see that we can communicate with this stuff inside. So we've seen various use cases for this. You could actually run a node outside of Kurtosis connected to the stuff inside of Kurtosis. You could obviously make RPC requests in order to do any sort of debugging that you wanted, or like make the network do anything that you'd like. And yeah, so that's pretty much the host port binding. So coming back to my what I was originally talking about here, the reason that Kurtosis asks you to define the ports both is to expose it and to allow you to bind things on your local machine. So this is all just various Go logic in order to define basically a class for those who come from Java. And this is the real meat and potatoes of what's going on. So this, each of these launchers implements a launch interface, and that launch interface contains a bunch of information that the node can use in order to start out. So Enclave Context, this is actually the handle to the Kurtosis engine itself. So if you want to manipulate the contents of the Kurtosis enclave, this is how you would do it. And this is the Kurtosis SDK. We have the image that the user has requested to start this with. We got the log level. We got the global log level as well, which is all corresponds to this guy. So all these different parameters get piped down to the launcher. So if the user would specify a new image right here, if they specified a log level, or they specified the global log level right here, you can see that all of those parameters get piped down right here, as well as extra parameters. And then it's basically up to us, up to the launcher to do whatever we want. Now, we've written all of this for all you guys, so you don't have to deal with any of this. But the real work is getting done with this git container config supplier. So every time you launch a service inside of Kurtosis, Kurtosis says, hey, please tell me how to start this container. And if we go ahead and scroll down to this function, we can see that this is a function which returns a function. A little bit confusing, but this is the function that actually starts your actual container. All this stuff, which looks kind of complex, is actually just initializing the file system on the container. We're not super happy with the way that this API works, so I would say don't fuss too much about this. We're actually going to be simplifying this in the near future in order to make Kubernetes compatibility work. And then you have a big command here to launch the actual Geth node. We add a couple more flags, like if this is a boot node, for example, add the boot nodes flag, pretty standard. And then we go ahead and tell Kurtosis the information. So we say, hey, this container is going to use those ports that we declared up top. We have an entry point override in this particular case, which is, if you're not familiar with Docker files, it's basically just a thing to tell Docker how to do a various a way to start a container, and then a command is basically an additional part of that. So once we have this function, we basically have a factory for manufacturing Geth nodes. So we come up back up here in the launch function, we have this factory, so the container config supplier. And then we just give it to Kurtosis, and that will go ahead and create our node. All this extra stuff is just going ahead and making sure that we wait for the thing to become available before we return it to anybody else. Does that make sense? Is there anything confusing about that? Okay. So the kind of the meta point that I wanted to explain with this is that, like, let's say you had an extra flag. Let's say there's a kiln specific flag that needs to get added. You could add it right here. So in that JSON, we saw that there was a extra params, these extra params things. So you could add it right there. But if you'd like everybody who's testing with your client to get that upgrade, then you can go ahead and actually modify the ETH2 merge module itself. So this is open source first. This is a Kurtosis Tech ETH2 merge module right here. And then you can go ahead and find your launcher. I usually just use the go to file. I'll go for a launcher. And we can see there's all these different launchers. There's Bezu launcher here, there's Geth launcher, Prism, Nimbus, Lodestar, etc. And scroll down. Every single one of them has this big long flags section here. And you could be like, oh, you know what? I want to add another one of these right here. Go ahead and submit a pull request. We have CI hooked up for this repo, so you don't have to worry that you're going to accidentally break something because everything will be groovy. And actually, Pari has been submitting a couple PRs very kindly to make sure that things are going ahead and working. So feel free to modify these. That means that anybody who tests with your client will basically have everything good to go and working. And Pari, I think that if I'm not mistaken, that you're actually starting to run this module instead of CI for the various different clients. So that will also help with Pari's testing and making sure that every night that you're building your client. So lastly, we can come back here and we can see that the module has finished. So we were stuck here. This took about 10 minutes on my machine when I'm not screen sharing, when I don't have Golang open and everything like that. I would say it takes probably about 1 to 2. So I promise this is not this slow normally. And we can see that we're just adding 1 Lighthouse client. We also add a transaction spammer in order to make sure that there is some load on the network. Marius, if you're online, thank you so much for helping me with that. So that will just be submitting just a bunch of small transactions. We have a couple pre-initialized accounts in the Genesis, and it just shuffles stuff between them. It's not really doing anything useful, but it is adding load.
Is that its own Docker container?
It is, yep. This is.
I'm not wrong, it's the same fuzzer we use on the test nets. So it just does transactions and then switches around fields.
That is this guy. Oh, excuse me. Actually, Marius's version is a library, and we have Dockerized it. So I'll add that too. So that gets started. That gets started with Kurtosis. And if that's problematic for you guys, it would be pretty simple to just add a flag to the module that doesn't add this stuff. Pretty much any of this admin stuff, I guess you'd say, doesn't get. We could flag it off if we wanted to. And then lastly, just a couple of debugging tools. So we have Forkmon, as well as Prometheus and Grafana. So Forkmon right here. We'll go ahead and see that it is showing things working here. And I'm not 100% sure why this is. Sometimes it seems like, probably, I don't know if this is a bug with Forkmon where we get to the 00000 root, but this is in fact working, even though it doesn't show it. But I use this for the Epoch a lot. And when you have a lot of clients, it's pretty useful to see if everybody's on the same route. Because when it is reporting routes, I think there's like a little bit of delay in Forkmon or so. I think it might be like a small bug. So if you have like, say, 4 clients going on here, then you can see if they're all agreeing on the same fork or not. And then we have Grafana. So this is almost definitely going to be still broken due to that bug in the demo from last week. Our engineer is on vacation, so he's going to be coming back on Wednesday to fix that. So this guy, once it's working, then you're going to, please go away. Please go away. You're going to see peer information, and you're going to see block. Oh, excuse me. Actually, I need to take this dashboard link here. And the module, by the way, you can think of modules like functions. So they took in the JSON parameters and they spit out JSON parameters as well. And these are just kind of like useful things in order to interact with the module. We can really report any information that we want here. There's probably going to be a world in the future where like the pre-funded accounts in Genesis are also reported here. That's like really not a big deal. So we can see right here that right now we've got them with the bug. But once it's going to be working, you're going to be able to see all the different clients, see what their beacon head slot is, see what their peers are. We could add EL peers as well. This is currently just the CL clients. So that was kind of the overview of Kurtosis, like what Kurtosis is doing, what the module actually does, and how to interact with the module, how to debug with the module. If you want to, if you have the Docker desktop, you can go ahead and feel free to do logs right here. Feel free to use the Kurtosis CLI if you want. Shell back and forth. We've got the Enclave Dump in order for you to dump information about an enclave outwards. Oh, one other thing I should mention is that we actually have the ability to attach REPLs. So Kurtosis Enclave OS, Enclave expect here. We can do Kurtosis REPL new and then add this. And what this will do is this is going to start us a node REPL as a container running inside this enclave, so you can start interacting with stuff directly. So for example, if there's anything that you weren't able to do through these ports, you can go ahead and do it from directly inside of the enclave. And So, we can see that we have this node REPL here. We have tab complete here. We have that Enclave Context object. So again, the Kurtosis SDK, which is imported inside of this REPL right now. So if we wanted to do something right here, and we do have the await available for those who use TypeScript, and we can see that any information that we're able to do inside of the module using the Enclave Context, we can go ahead and do right here inside of the REPL. And the last little bit of information, kind of a feature that I'm personally proud of because I think it's kind of neat, is rather than like you might not have a package that you want. So for example, if you wanted others.js inside of here, we can go ahead and do Kurtosis Enclave inspect on that enclave. And now we have both the enclave ID and the GUID of this interactive REPL. And then if we do Kurtosis REPL install, grab the enclave ID, grab this, and then pump in the package name. Kurtosis will actually in the background install the package inside of the your REPL. So then it will become available to you, and you can start using that inside of the node REPL. So if you wanted to communicate with, the services inside of the enclave from inside the enclave, then that would be doable like that. And now we can see that we have others. And we got others. Benefit of communicating inside of the enclave. Each of these enclaves have a service ID here, which is the first part of this without the stuff after here. And we can see that the service IDs are right available right here. So EL client 0, CL client 0, etc. When you are working inside the enclave, so when you are not going through these ports, you can actually use the service ID as a hostname. So I'm not super familiar with JavaScript, but if I had like a ping, right, I could do like ping CL client 0, and that would work. That would actually that is the domain name of the CL. Can you guys hear me again? Yes. Okay. These guys are real pain. Okay, so that was kind of a quick overview. We're getting close to the end here, so the last thing I want to give you guys is just a couple bits of docs in order to make your life working with Kurtosis easier. So all of our docs are found at docs.kurtosistech.com. I'll send that to the chat. So we have everything. We have a quick start, which is basically if you just want to get going from 0 with Kurtosis, you actually run, you do set up an Ethereum network, and you actually write a TypeScript unit test against that Ethereum network. We have the installation docs that I went ahead and showed earlier. We have tab completion on Kurtosis as well, because basically it's a real pain to remember everything. We have using the CLI docs. So basically all the common operations that you end up doing inside of Kurtosis, you can go ahead and use this as your reference for the CLI. Everything in the CLI as well takes in a -h flag. So we got Kurtosis -h, we got Kurtosis Enclave -h, we got Kurtosis Enclave ls -h, all this different stuff to show all the different flags. So anything that you need for that, you can always pass in the -h. And then we also have right down here, we have documentation for the actual Kurtosis SDK. So just in case you want to use a Kurtosis SDK, like let's say you wanted to use Kurtosis to write your own unit tests, you could go ahead and see how this is done here. So you would always start with a Kurtosis context. This is kind of like the top level connection to the Kurtosis engine. It's what allows you to create enclaves, destroy enclaves, that sort of thing. And then when you call create enclave, you're going to get back an enclave context. And that enclave context is what we saw before here. And that has a bunch of enclave specific information. So you can go ahead and load module, in this case, the Ethereum 2 merge module, if you wanted to set up Kurtosis inside of your enclave, inside of a unit test, which could also be done inside of CI if you wanted. and unload module and all these various different things. You could add a service if you wanted. You can simulate network repartitions. So this is one of our, let's say, a little bit more advanced features, is that we could actually simulate partitions between arbitrary various different services that are going on inside of the network. And that's pretty much what I got. docs.kurtosistech.com. We have a Discord as well. So that should be on our, it's here. Yeah, here we go. So we have a Discord. We have a merge channel on the Discord here. So we got the ETH merge. Feel free to show up there or just show up in general. Again, I am on this Discord. I'm Kevin today. My handle is Nibris, which looks like this. Or you can just mention me with Kevin today. If you had any problems at all, please don't hesitate to scream and let us know. We are a startup, so we're trying to make sure that our product is as awesome as possible, and we want to make sure that we're responding to your guys' pain, if there's any pain at all, as quickly as possible. So please feel free to shout at us. It makes the product better and makes your guys' experience better. So don't be shy about that. And that's all I got. Pari, I don't know if you wanted to briefly mention the running in CI thing, or if like there's anything you wanted to chat about with that.
I think if people have questions, we can do that first, but otherwise I'd love to give you guys an idea of how that looks in the CI.
I'm curious about how you think about Hive versus Kurtosis.
Yeah, so so we started Kurtosis actually in the Avalanche ecosystem. So that's kind of where Kurtosis started and how it grew out into. So when we started engaging with Pari and folks, it sounds like the Hive, from my understanding of Hive is focused a lot on like unit tests. It's kind of like, or not necessarily unit tests, but mocking very specific things in order to do very specific scenarios. So when we were poking through the Hive code base, I think there was something where there was one like drop certain packets to simulate like block delays, if I'm not mistaken. So Hive, as I understand it, fits very well for the use case of where you have like 1 to 2 clients, where one of those might be mocked, for example. And Kurtosis right now is doing the, like, I guess you'd say like the 1 to n. So you could set up one client inside of Kurtosis, but you also have the ability to set up all the way up to n, up to the limit of what your machine can support.
Right, okay.
I also have a question. This is great for CI, but I'm trying to figure out how it would be used also for a dev perspective while you actually developing things and you have something running on Kurtosis, and you at some point you want to deploy a bug fix in your running network. So, is it an easy way to do? Or you have to actually deploy a new image, and when you start it again, actually the network needs to be restarted completely?
Yeah, so actually so if you use the host name as the connection parameter in between different nodes, you can stop. And you would just do this with the Kurtosis SDK. So you could do this with the node REPL, or you could do this with like the Go REPL or anything, Go SDK. You could shut down one of the running services and then tell Kurtosis to add it again, and with the same service ID, and then it would get the same domain name, and then all the traffic that was previously erroring when trying to connect will go ahead and do that again. It'll basically like the connection will heal because the domain name will exist again. So that would be your use case for being able to like pull out a service and add it back.
And you can use a different image in that case, because you have to redeploy manually specifying a new image, right?
Yeah, you would basically just specify whichever image you want to drop into place. And Kurtosis will always try to use the latest version of the image. So the dev flow that, and I'll caveat that I haven't done this before. So, so I know the domain name. I know the domain name will work because that's a Docker feature. It's not something that we do. But the dev flow that I would imagine is that you have your repo, which is building the image, and then you have a Kurtosis network, and you're like, hey, there's a problem with this. So you tell Kurtosis, hey, please rip down this service, and just
Right.
Cool, done, got it. Container is stopped now, so that the domain name is now free, and all the other network is failing to connect. Build your new image, and then tell Kurtosis again, hey, can you please add this new service with the same service ID? Service is back, started with your new Docker ID, or your new Docker image, and then the domain name is back.
I mean, maybe this kind of workflows could be highlighted in some additional docs. So maybe that then help us as also the developing part, and we could leverage it.
Yeah, it's a super cool workflow, and actually, like, one of my lasting regrets is that we haven't had the time to build a Kurtosis service like new or Kurtosis service remove command, so that you have to go through the SDK, because I think it would be really awesome if you could have the CLI where you just specify Enclave ID and service ID, and Kurtosis will tear it down for you. It actually wouldn't be that hard to build. So if that's something that's super useful for you, I don't want to promise like in the next couple of days, but like I think like maybe in like 2 weeks time or so, I think that could be something that we could definitely build.
Yeah, this definitely helps also the dev side of it instead of the main objective, which is the CI, I guess. And also, I was wondering. I saw that in your JSON you have the way of add additional parameters, but I saw during your presentation that it's not possible to override existing parameters coming from the launcher. Is something that it's possible to actually specify completely new set of parameters and overriding everything?
So this is going to depend a lot on the type of CLI that the binary is using. So the some of the CLIs I know that if you just add new parameters at the end, it will actually take the latest parameter. I think this might be a POSIX thing. So you could just add extra parameters to override, but I know some of them don't. I've tried this.
It depends, right?
Yeah, but that would be in my opinion, like I don't know if there's like a way for you folks to specify like, hey, like take ones at the end. That would be basically the easiest way, because otherwise we would be otherwise we would probably have to specify no parameters, then people would have to specify everything. There might be a clever way to do it though, but I think adding them at the end would be the simplest.
I mean, there is the override, but then the additional parameters, but maybe an complete override option where you have to simply don't rely on the default one you want to spin up completely manually. It could be maybe useful.
Mm-hmm. Yeah, 100%. Okay. Yeah, that's everything I got. Pari, I don't know if you wanted to run through the CI workflow really fast or.
Sure, I can do that. Maybe I can share my screen. Hang on. Yes, I guess you guys can see my screen now.
Mm-hmm.
Okay, so what I've done is I've taken the Kurtosis stuff and tossed it into a small integration test. And this will be divided into two parts. So the first part is the merge client build, because there's currently some clients who I rely on to provide me the latest image. So instead of relying on them to provide me the latest image, we can just build them ourselves. And this gets triggered every day at 2 a.m. in the morning. So what I've done here, hang on, let me just show you the workflow for get, for example. So there's two ways you can use this. First one is you either manually run it, and when you manually run it, you can specify which branch you want to use, or it just runs on a schedule at 2 a.m. And when it runs on a schedule, it just default builds the merge kiln branch. So I'd get the latest get image from the merge kiln branch. Then this CI gets triggered at 3 a.m. automatically. And I've basically listed the base parts of everyone's Docker Hub repo. And then there's a small script that says fetch latest image tag, along with what the base image is. So it'll go there, it'll fetch the latest image, which if you recall, would have just been pushed from the previous CI, and then tosses all of them as environment variables. Then I've taken the Kurtosis config as a template, and that spits out the like the templated version essentially. So now we have the Kurtosis config with the latest images, and then it just runs the module with the image. And what they've done is there's a wait for finality check. Right now, that's the only test. So essentially, finality has to happen by epoch 5, which is 1 epoch later than the best case scenario. And if it doesn't happen, it fails. So essentially, in about 30-ish minutes, you'll know if your CI passes or not. And in some scenarios, that won't happen. And just to trigger such a scenario, I switched out the Teku image to the latest. And Teku's already implemented the renaming, whereas Get hasn't. So Teku Get will actually break. And as you can see, that's exactly what happens. If you go to the CI run, you'll see that the finality didn't happen in 32 minutes. And because we want to later figure out what actually happened, if you watch this repo, every time it fails, you get an email. If it passes, you just get an email saying it succeeded. So if it failed, I just run Kurtosis dump, so you can get the entire logs, check it out yourself. Let me just show you what that looks like. And for example, CL client 0 is Teku. And if you go forward, you can see, oh yeah, look, unwrapped response thrown. Teku is basically not happy, and then figure out what actually happened. It just does some cleanup stuff. I'm running everything self-hosted right now. I've reverted it, so it will work again. And when it works, it still dumps the logs in case you want to have a look at what happened. And yeah, if you guys want to stress test this or have your own CIs doing different combinations, like previous version plus current version or something, then just copy out this template, change whatever you want to do, and you can have your own integration test. I would need, I guess once we have the V2 spec deployed, this would be a lot more useful, because currently, since we're changing the spec, this would break a bit, but maybe in a week or two, it'll actually make sure we don't have any regressions anymore. Yeah, I think that's it. Anyone has any questions? Cool.
And one thing to note that's really cool is that Pari, you did the Enclave Dump at the end of the CI run. We found this to be super useful. So basically, if your Enclave fails, if your CI fails, then you basically have the log package in order to debug. We do that inside of our own internal CI for Kurtosis anyways.
Exactly. And then I just ran a cleanup script later on. But yeah, feel free to rip it off, use it in your own CI. One place I see it being really useful is testing your past version with your next version, so you don't have incompatibilities between your releases. And we definitely need help writing more tests. So we currently just have the finality test. If you can think of other scenarios you want to put an integration test through, then do reach out, and then we can figure out how to make it happen.
Okay, so Kevin, I have a question, follow-up question with regard to the development scenario that Enrico talked about. And so basically everything is Docker network, right?
Yes, sir.
Behind the scenes. So it is possible that, while Kurtosis is running and has its enclave up, we can manually spin up our own client and plug it in the network and sort of interface it with other nodes. It should be possible, right?
You mean using the interface with the domain name? Or?
So yeah, we'll definitely make sure that that if it needs to hook up to other ports, it will be able to hook up. But it should be possible that I can spin up, provide all the relevant endpoints, API endpoints, and CL or EL should just work, right?
Yeah, totally. You can do this. You can do this either inside or outside if you want. Like you could actually run. So for the near foundation that we're working with, people run it outside of Kurtosis pretty commonly actually. So you'll have the network running inside of Kurtosis. You'll have those public ports on your host machine that for connecting to it, and then you can just tell your node that's running, say like outside of Docker, say, hey, please like connect to those ports, and then it'll the connection will just travel back and forth.
Right. So then we even have to spin up a Docker image.
Yeah, you wouldn't even have to spin up a Docker image.
Yeah,
and yeah,
that's
sorry,
cool.
Enrico, maybe I was misunderstanding. That's like that is the easiest way to develop that.
It depends if it is exposed also the P2P port UDP. I mean, if it is exposed, I think you can join.
Yep.
Network.
The only thing that might be weird is that because Docker does like IP multiplexing, basically, the gossip might be a little weird. But like if you're connecting directly to the network, like if you give the RPCs of like several nodes, then you should be good to go. Any other questions? Anything else I can help answer? Okay. Well, as always, I'm on our Discord. I think I'm probably on a couple of your guys' Discords as well. If you have any questions or want to ping me, definitely feel free. All right, everyone. I hope you have a great day, and we'll chat to you all soon.
Thank you guys for joining today, and I'm gonna upload this video recording later on the Ethereum Context YouTube.
Sounds great.
Have a good one, everyone.
Thanks, Kevin.
Thank you guys.
Thanks. Bye.